Hello students, in today's video I am going to share a trick with you which is regarding how to calculate time constant for an LR circuit. Actually, you can calculate time constant for a complicated LR circuit with following few steps that has already been written here and circuit has already been drawn. So say this is example 1. Circuit is given. Normally if only one resistance and one inductor is there in the circuit, then simply time constant can be written as tau equals to L over R. But when some complicated circuit, when it is having three resistance, then how you can calculate time constant? So there are few steps to be followed for calculating the same, and I will discuss one by one. I am taking this example. Step 1 is short circuit the battery. Means first we have to short circuit the battery. Means we will join the battery by a simple wire. This is called short circuiting. In next step, what you have to do, you have to disconnect the inductor. Disconnect the inductor means put it into open circuit. So if inductor is connected here, so I will visualize like that. It is disconnected now. Then our step 2 is completed here. This is step 1, means short circuiting the battery. Now I have disconnected the inductor. That is step 2. Third step is calculate the effective resistance across inductor. Means across disconnected terminal. So these are the disconnected terminal. I can put this inductor outside, like I have cut and removed, and it is placed here. These are the terminals. So I have to calculate equivalent resistance for these two terminals. Say it is P and Q or I or B, whatever I can say. So how much resistance is offered for these 2 points? Means I can draw the circuit like that. At 3R resistance can be drawn here, and B terminal can be shown like this. Now resistance between A and B will be this resistance having value R and 2R are in parallel. These are connected on this point, so these are parallel. So if I solve parallel for this R and 2R, I would get, say it is R dash, then R dash equals to 1 over R, 2 over R. So effectively it will come R dash, that is equivalent for these two resistors. It comes out to be 2 by 3 of R. Now this 3R resistor is in series for A and B. Therefore effective resistance across AB, or I can say across this inductor which we have cut and open from the circuit. So it would be 2 by 3R plus R, because 3R, because 3R is in series. So if I solve it, it would be 2R plus 3 is a 9, 9R. Further it is coming 11R, 11R over 3. This is the effective resistance across inductor. So now by using these three steps, we can convert this circuit in a simple LR circuit. Means this is the effective resistance, and this whole circuit will behave like a simple circuit having R effective here. That is 11 R by 3, and this is L. In next final step, or we can say in step 4, you can write time constant of the circuit very easily. That is by using formula. Step 4 is use formula L over R effective. So R effective we have already calculated. So therefore it would be L divided by R effective, means 11 R over 3. 3 will come over here. 3L over 11 R is the time constant for this circuit. This is the first example. Now one more question is also here, wherein we have to calculate time constant, and further we have to calculate time dependent current in L in both the condition during growth of current and during decay of current, and it is given that switch is closed at t equals to 0. So first we have to calculate time constant. So same procedure we will follow that we have followed in the earlier question. Means we will repeat this question. Short circuit the battery. First short circuit the battery means you can draw a circuit like this. Battery short circuited, simple. We will connect the wire. This is 10 ohm, this is 5 ohm, and inductor is here. In second step, we have to disconnect the inductor also. So I am taking it out from the circuit. Inductor is connected between these points. So I am showing it here. That has been disconnected. Now I have to calculate effective resistance on this point. So it is clearly seen from the figure that 10 ohm and 5 ohm are in parallel combination. So effective resistance for this value will be 1 by 10 over 1 by 5. It is the effective resistance because only two resistances there. On solving, you can get R effective would be 2 by 3 of 5, or I can say it would be 10 over 3 ohm. This is the effective resistance. In next step, we can write time constant. Step 4, time constant can be tau equals to L over R effective. L is given, L is 1 millihenry. So I can say this is 10 raised to the power minus 10, 1 millihenry divided by this thing, that is 10. 3 will go up, multiplied by 3. This will be in second. So tau would be 3 into 10 raised to the power minus 4 second. This will be the value of time constant. So we have solved up to here. This is the first part. Now we will get an idea regarding the time dependent current for an LR circuit. So how you can calculate time dependent current, that is can also be calculated very easily, simple formula based question. Now we have to calculate time dependent current in L during growth of current and during decay of current. Then what further need to be done? I will show you. During growth of current, time dependent formula is given by this equation. IT equals to I naught, that is peak current, 1 minus e raised to the power t over tau, where tau is time constant. So tau we have already calculated. Now we have to calculate I. Then we can write this equation. For calculating I naught is actually peak current. We use this graph. I naught is the peak current that is corresponding to very long time, or I can say t equals to infinite. And corresponding to t equals to infinite, inductor will behave like short circuit. Means if growth is taken place for finite time or very long time, then inductor need to be replaced by a simple wire. Means inductor will be there, but it behave like simple wire. In that case, you can calculate peak current. If this is 30 volt, now because it is short circuiting, then whole current passing through this resistance will be passing through this path. Means if short circuiting terminal is there, then no current will pass through 5 ohm resistor. Current will be 0 in 5 ohm resistor. So we can say circuit will be like this. Only 10 ohm resistance will come into play for the peak current. Therefore, peak current will be battery potential, that is 30 volt. 30 volt divided by resistance, that is 10. This is value of I naught. Further, you can write 1 minus e raised to the power minus tau minus t over tau, and tau is this. So you can write t by 3 here, and this factor will go up. Either first you will write like this. You can leave it also. It is also correct. It equals to, here is 3, 1 minus e raised to the power 10 raised to the power 4t by 3. This would be the time dependent current during growth in this LR circuit. Now, during decay also, we can write the equation. Transient behavior during decay is given by this equation. IT equals to I naught, that is peak current, that would be the same when it is completely, current has completely grown up. E raised to the power minus T over tau. So I can write it. During decay, it would be Same value I naught is same, that is 3 e raised to the power t by tau. That would also be the same, 10 raised to the power 4 tau by 3. This is equation in case of decay of current. So I think by these two questions, the concept of calculating time constant for a circuit would be clear to you, as well as I have also shown how you can write the equation for growth of current and decay of current in an inductor. If you are finding videos are useful for you, then subscribe the channel and share the videos with others. The person in need, they can also get some help from these videos. Thank you. Thanks for watching.